Boom, level 1 reveal. We have officially finished level 1 and I'm here to show it to you guys. If you've been following along, we have been updating you with all the different systems and mechanics that we've been implementing, such as the water cooler, like meaning the interactables, the enemies, health items, and now I get to show you how it all interacts together. In this video, I'm going to break down how enemies work, how health items work, how the elevator works, and what exactly we did to make sure that this level came together. That includes all the code and even the movie magic that goes into making a level. So the previous recording was actually a run through of the first level. This, however, is what the level looks like in our editor in Unreal Engine. Because we're using Unreal Engine, which is a 3D engine, we can't really do traditional 2D development in it. So what that kind of looks like is fudging the 2D effect. All of these actors are actually on a 3D grid. So this is a tile map that we ended up painting and dropping into the world. And over here is the player start. So you spawn in at the beginning of the level and the tile map has collisions on specific layers, such as the floors or the walls or the ceiling. So basically you're trapped inside this box right here. One thing that is kind of annoying that we have to do is for every single platform and all of our actors that we want in the game, we have to manually place them instead of just being able to paint them on the tile map. That's just because that's the way I was able to figure out how to do it, because there's not really a whole lot of tutorials or information about 2D development in Unreal. Starting off, I guess I'll go ahead and show you the tile map first, because that is probably the most important and newest part of level 1. One thing that I'd like to point out is that all of these tiles are painted on individually on all of these layers here. So as you can see, we have quite a few layers and all of them have their own collision settings and specific settings for them. For example, Void Fill wouldn't have any collision on it because you're not supposed to get outside of the walls. It's not going to happen. So what that means is that we can just kind of turn that off. Now for something like the platforms, we also have to turn that off because we aren't placing these via the tile map. As I said earlier, we have to go in and manually place them one by one as actors. And that can get really challenging as you have to line everything up and be pixel perfect with everything. So what we can do is we can go on all these different layers and paint. So we painted the floors first, we painted the void, and then all the other stuff, meaning the decorations and the platforms. Our tile map is actually 500 by 500. So that means it's 500 tiles wide by 500 tiles tall. As you can see, our map's kind of big for what we are actually using here. One thing that is important to note is that all of our tiles are 16 by 16. In case you were wanting to do your own type of 2D development in Unreal, this is kind of like a good blueprint. So this right here is the blueprint for our office worker enemies. They consist of a player detector, a wall pass-through detector, a ledge detector, a wall detector, a sprite, an arrow component, and then it also has a blueprint component called BPC Enemy 1 and has a character movement component. The player detector detects a player, the wall pass-through detector checks to see if they can move through a wall, the ledge detector checks to see if they can see the ledge and turn around, and the wall detector detects if there's a wall so that they can turn around. BPC Enemy is where we hold the information for the states, such as attacking, idle, moving, that kind of stuff. And it also holds the sprite information for our enemies. I'm going to go ahead and show you the actual code for this, but it's going to look really small because the office worker is actually a child of the base enemy. And the base enemy is where we hold a lot of the information for our office worker. If I go ahead and open this up, you can see this is all the code for the office worker. If you can see here, it's doing all of the logic that the base enemy is doing by attaching this parent begin play node and the parent begin overlap node, meaning that I didn't have to rewrite all the code for this specific enemy. I just had to make it a child and it copied it all for me. So that was really nice. If you look over here, this is all the logic for the player detector. It doesn't look like much, but that's because I made it pretty self-explanatory and broke it down into components and functions and things of that nature. If you look over here, it starts with a Boolean that checks if the enemy is attacking. Then, if the enemy is attacking, it switches states into the attacking state, which is held inside of our blueprint component. Now, a blueprint component, let me go ahead and open this up really fast, is actually something that you can add onto an actor that holds all of the logic that you put in there. So basically, it's like a compartment that I can put a bunch of different logic into and add it onto any actor that I want, instead of having to add all that code individually. The player detector checks if the enemy is attacking. If the enemy is attacking, it then switches the enum state to attacking. Then it runs this function right here that says stop base enemy movement. And what that does is it casts to the main character, and if the detector detects the main character, it stops movement. Once the enemy stops moving, it runs into this function that fires every 0.1 seconds called handle enemy separation. Now, what handle enemy separation does is that it separates the enemies if they are overlapping each other so that they don't stack up. And this only happens if the enemy is attacking. From then, we choose our state, which is in the blueprint interface base enemy. And then from there, we set this timer by function name, and that runs every 1 second, and that is throw binder for timer. So this is the throw binder for timer function. Now what this does is that it runs a little check that says if the office worker is not dead, spawn an actor, meaning our projectile that is selected at the beginning of play by that state selector, the enum, and then it sets the thrown object in BPC enemy 1. And then finally what we have over here is a little event that says when the player detector is deactivated or not overlapping, to deactivate the player detector. So what this does is that it casts to the main character, it sets attacking to false, it sets base enemy movement to true, and then it clears our throw timer so that it no longer throws, and then it sets the flipbook state to walking, and then it tells the blueprint interface to choose that state. Now finally, for the office worker enemy, we have the state selector. Now this top state selector here is mainly just for the sprites and movement logic. Basically what this does is that whenever you saw that green box that said attacking or idle or whatever, that is what is selecting the state. It's called an enum. So when that enum is idle, walking, attacking, or dying, it switches between them. It either sets the flipbooks, like in idle, right here, or in walk, right here. But it also sets collision responses. Like right here, it says that when walking, it should ignore enemy. And over here, it sets the actual movement to walking. Right here, it sets the throw footbook, and over here, when it's dead, it sets the Boolean is office worker dead to true, sets the dead flipbook, and then it sets like all of the logic that would happen after the enemy has died. So what it does is that it sets it to hidden, and then it goes ahead and adds points to the game. So when you kill an enemy, you get points. And then down here, what we have is what selects our random skins. Now this is honestly my favorite part of the entire office worker because I just think it's the coolest. We are calling this custom event anywhere that we are trying to set flipbooks. So that is happening actually in our base enemy. So you will get to see a little bit of the base. So in this base enemy, we randomly select flipbook types. So if the flipbook is not initialized, it's going to then initialize and choose a random skin. So over here we have a struct that holds 12 array elements. So those are the 12 skins I was talking about. All of them have 4 different flipbooks that they switch between depending on their states. And they also hold a projectile. So as you can see here, I selected BP Binder for the projectile for our office workers that are holding the binders. If I go ahead and scroll through here, you can see that there are the other ones that have coffee mugs, and we also have people who hold plants, little cactus. Those are all of the skins that the office worker could select from. So what it does is that it takes all of those, gets the length, subtracts it by 1, and gets a random integer from that list. So basically it's saying get a random selected flipbook set from this list, and then set those flipbooks into these variables, and then set those variables into this event, which then is called our BBC enemy, where it sets our cache flipbooks per office worker. So that is everything for the office worker. I can go more in depth over all of the actual logic in the base enemy character, but we are running out of time for this video. So if you'd like to see more of that, please let me know down in the comments below, and I can show you the full logic breakdown of the enemies. Like I said earlier, we are running out of time in this video, so I do apologize for not getting around to the water cooler, the donut, and the elevator. I will go ahead and explain those more later on. Stay tuned in the future for more updates, and I hope you all enjoyed.